Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is Hazim Hamidi, MA 19314, student in Mechanical Engineering from University Malaysia Pahang. So today I'm going to present and discuss about the analysis of hand pump from subject Dynamics, BMM 1553, taught by Dr. Ahmad, Razlan and Yusoff. The first chapter for this study is Introduction. So what is hand pump? Hand pump is a manually operated pump by applying mechanical knowledge to move fluids or air from one place to another. A hand pump is used for both community supply and self-supply of water. Then what is the function of hand pump? As I just said just now, hand pump is function to move fluids or air from one place to another. The relationship between hand pump and dynamic studies is the hand pump consists of a kinematic system. Therefore, this study will include the study of relative motion analysis from the dynamic subject. The second chapter for this study is about the problem statement. There are a few problems to be studied for this case. The first one is modifying the old design of hand pump. We are going to create or modify the old design of hand pump and create a new one, but the function will be the same. The second problem statement is to create a new model for hand pump system. The third one, what is the angular velocity for handlebar of the new hand pump if the piston inside the cylinder is moving downward at 4 meters per second when the position of connecting rod is 30 degrees. When we are creating the new hand pump, the hand pump will have a handlebar and the piston inside the cylinder. But in one condition, the piston is moving at 4 meters per second and the connecting rod between the handlebar and the piston is at 30 degrees. Next, what is the best method to solve the problem? Then, does the new design is acceptable? We are going to analyze and solve all of this problem statement in the next chapter. The next chapter is about the objective of the study. The first objective is to provide a new design of hand pump with the same function. The second objective is to determine the angular velocity of the handlebar of the hand pump when the piston inside the cylinder is moving downward with velocity of 4 meters per second. The third objective is to provide a full calculation using relative motion analysis method. The relative motion analysis method is about getting the final answer from the problem statement, which is the angular velocity of the handlebar of the hand pump by using the manual calculation. The next objective is to compare the value of parameter in the system gained from relative motion analysis method and GIM software. The last objective is to provide a graph for every parameter on each point in the system using GIM software. We move to the new design of the system. So this is the new design of the system. If you can see, there is a handlebar from point A to point B, which is 2 meters, and then the connecting rod to the piston from point B to point C is 3 meters. Then there is one condition of the piston inside the cylinder, which is the velocity of the piston is 4 meters per second when moving downward. The next chapter is about the working principle of the new hand pump. The function of the new hand pump is still the same with the old hand pump, which means the hand pump function to transfer fluid or air from one place to another. The connecting rod BC has the angle of 30 degrees, and the piston to move downward when the handlebar AB is pulling down. This is the process when compressing the fluid or air inside the cylinder. Next, the piston moves upward and suck out the fluid from the cylinder. This happens when releasing the handlebar AB. Then we move to the method to solve the problems. The analysis of the hand pump can be divided into two sections, which are relative motion analysis method and GIM software analysis method. Under the relative motion analysis method, we can use manual calculation to get the result. In addition, for GIM software analysis method, we can use the simulation method to get the results, including the graph for all the parameters in the analysis. Next, we move to the relative motion analysis in manual calculation. This is the manual calculation for the new design of hand pump. Firstly, the free body diagram needs to be drawn to show the parameter that exists in the system. For example, the velocity of the piston is 4 meter per second. Next, assign the possible parameter in the system besides the angular velocity of the handlebar AB, such as distance between point B and point C, the angular velocity of the connecting rod BC, and velocity at point B. These are the free body diagram for the parameter besides the angular velocity at the handlebar AB. Secondly, we need to find the lengths of points B and C by using the vector method, which is I and J component. The length of point B and C can be calculated by using Pythagoras theorem, since there is a right angle shape with an angle of 30 degrees. This is the Pythagoras theorem with the angle of 30 degree position. Then we can find the length for the connecting rod BC by using the ING component based on the x-axis of the Pythagoras theorem, which is 3 cos 30, plus with the y-axis of the Pythagoras theorem that get from 3 sin 30, and this is the length for the connecting rod BC. After that, all the parameters need to be inserted into an equation of velocity at C by using methods which are I, J, K component as shown in this calculation. This is the equation for velocity at point C. The velocity at point C is negative 4 meter per second, thus it consists only at y-axis. So the vector is negative 4j and equal to negative 2 WAB, which means negative 2 angular velocity at AB plus omega BC at K times with 2.598 I plus 1.5j. This is the length for the connecting rod BC. This is the angular velocity at BC. This is the velocity at point B. You can get from the free body diagram. Then sorts all the parameters based on their vector component ijk to get the value of an angular velocity for connecting rod BC and angular velocity for handlebar AB. So the final answer and the answer for the problem statement is 2 radian per second, and the angular velocity for connecting rod is equal to 0. This is the manual calculation to get the answer for the problem statement. The simulation method is divided into two parts, which are drawing the system using geometry in the software and simulate the system by using kinematic analysis in the software. The first step is to change the type of analysis in the option on the left side to geometry. Then select the point option and click on the grid. After the first point has been drawn on the grid, select the origin option and click on the first point that has been drawn. The function of the origin option is to set the first point on 0, 0 coordinate. After that, select the point option and click on the grid according to the system design. Make sure the distance between each point follows the new design of the hand pump as shown from the previous chapter. After all point has been drawn on the grid, click on the element option to make a bar. Connect all the points using the element option to produce a full system of a hand pump. In addition, add the slider follows the design of the new design hand pump. To complete the system, change all the points into a suitable joint, for example, revolute joint and fixed joint. The next step is to simulate the system in kinematics mode. First thing is to change the mode to kinematics. Furthermore, select one actuator to be used in the system to start the simulation. In this study, choose a slider displacement actuator to be used in the system and click on the system slider until the path of the slider appeared. Finally, set the velocity of the slider to 4 meters per second follows the condition states in problem statements. Then click on the play button on the left option to start the simulation. Finally, GIM software allows the user to study all the value besides the angular velocity stated in the problem statements. For example, angular acceleration, velocity, acceleration, and more else. Moreover, GIM software also provides the graph for all parameters to be studied. To see the velocity of the handlebar AB, you can click on the FX button on the left side and go to the query option, choose the element option and angular velocity, then click on the handlebar to see the value of the angular velocity. In addition, you also can check on another points for the velocity or other parameters. Chapter results and discussion. These are the kinematics graph for the study of the hand pump. These are the graph for position of piston, starts from 0.5 and end at 2. These are the graph for velocity of piston, which we set at 4 and it will end at 4. The next graph is about the acceleration of piston. The next graph is about the graph for angular velocity of handlebar. As we use the manual calculation to get the angular velocity of handlebar, we get this value, which is 2 for the angular velocity of handlebar AB. The negative 2 means the direction of the angular velocity of handlebar AB. The next graph is about the angular velocity of connecting rod BC. 0. The 0 value is same with the manual calculation of the hand pump by using the relative motion analysis method. Next, we are going to compare the results or the answer for the case study of the hand pump. We are going to compare the final answer or the values from both methods, which are manual calculation and GIM software. The first parameter is the velocity at point C, or the velocity of the piston. The velocity of the piston is determined from the problem statement, which is 4 meters per second. Thus, both methods should have the same value of the velocity at point C. The next parameter is about the angular velocity at the handlebar AB. Based on the manual calculation, the handlebar AB, we get the angular velocity at the handlebar AB is 2 radian per second by using the relative motion analysis method. In addition, the GIM software also get 2 radian per second for the angular velocity of handlebar AB. The next parameter is angular velocity at BC. From the manual calculation, by using the relative motion analysis method, the angular velocity at connecting road BC is equal to 0. Same goes to the GIM software. It provides the angular velocity of connecting road BC is 0 radian per second.